Hi there guys, welcome to a new tutorial video. In this video we will be looking at a sorted array of numbers, and we will try to find two numbers such that the product of those two numbers is closest to a given target. So in the first example you can see we're given an array of three numbers and the target is 30. So we want to multiply one pair of these two numbers together and get a number which is closest to 30. In this case that would be 6 times 7, which gives 42, which is just 12 removed from 30. In the second example, we've got a few more numbers, but if you evaluate this, you will eventually conclude that 3 times 4 gives 12, which is closest to 10. And so the purpose of this program is to either give us a combination of numbers which is exactly 10 or the closest one. So I suggest you pause this video and think about the problem yourself. Alright, if you pause the video, if you didn't pause the video, I'm going to continue now. So one very simple way to solve this problem would be to iterate over all possible pairs of numbers, then compute the product of those numbers and compare it to the target. And when we do this, we would essentially have to iterate over the entire array at least twice. Essentially, we would have to pick two from these numbers, so the time complexity would be O of n squared. And so that's not great. So can we do better? And after some thinking, yes, we can do better. So I have drawn a grid here with basically the array, the sorted array on each side. And the reason I've made this red is because it's symmetric. So this value is also here. Oh no, it's also here. I made a mistake. And so if we compute it once, then we've got both. And the reason that these values in diagonal are also red is because you can't pick those, because you only have one. You cannot pick the same element twice. And so given like this grid structure, what would be a way that we could find the closest target if we know that our target is, for example, 10? Well, then the plan I devise is we basically start at this point and we compute the product of these two numbers, which would be 6 times 1, which gives 6. And then we compare this to 10, and we can see that 6 is smaller than 10, but then it would follow that all of these guys are also smaller. So they're never going to be closer to 10 than 6. So you don't have to evaluate these anymore. So because this 6 is smaller, we're going to take one step this way, and we're going to compute the product of this entry, and this will give 18. Well, 18 is larger than 10. So if you go and increase it, you will be further away. So this is also an option you don't have to evaluate anymore. So when we have a larger number, we go to the left. So the argument is very simple. If the number which you evaluate is smaller than the target, then you move one down, else you move one to the right or to the left. Now, if you look at this comparison, it would be 3 times 12, which gives 12. Well, 12 is larger than the target, so we would move to the left to make it smaller. But as you can see, we get into this red area, which means we can't go there. And so there's no other option. We can't reach 10. So 12 is optimal. This is the best we can do, and this is the answer. So let's first write this out and then think about what the complexity or the time complexity of this method would be. And to implement this, I'm just going to create a function known as closest product, taking an array of numbers and the target value, and the array is sorted, so we can just write it down. Now we're working with a grid, so I'm going to just initialize two coordinates, x and y, and because I want to start at that very specific position, I'm going to make sure to set my x all the way to the right side of the grid. And then I'm going to basically start looping, because we have to do this iteratively. And the condition for the while loop that I'm going to use is I'm going to check while x is greater than y plus 1. And so basically, if you imagine the grid, we are only going to continue looping if we are at the upper triangle on the right of the grid. And so what are we going to do? Well, we're going to just probe, and we're going to see if the product of the array evaluated at x and y, oh, I forgot it, bracket there, if this is equal to the target. Well, if this is equal to the target, that means we have found a perfect match, and that means we can just return the array values because we're done. But in most cases we won't have this, so we have to also check the other cases. And so we also have the case where the product of our two numbers is less than the target. And so what we did in the example is if the product was less, we needed to increase, so we needed to move down with one position. Well, then we also have basically the final case left, because if it's not equal to the target and it's not less, then it's of course larger. And so in that case, we would subtract 1 from x. And this is basically the algorithm that we just described in the example. And at the end, we should just return the two values with which we are left. So after the while loop is done executing, we can just return these values and we will be done. So let's just see if this does return what we wanted to return. So I'll just take this array. It has an additional 7, but that's not really a problem. And let's save that. Oh yeah, that's a typo. Alright, as you can see, the pair of numbers which was returned was 4 and 3, which in this case is optimal. So now let's think about the time complexity of this method, which can be kind of difficult. It's not very clear, and it's also kind of hard to prove. But if you look at the grid, you can see that if we start at this position, we can reach any of the allowed elements in basically n comparisons, right? If I go this way, then I can do it in n-1 steps. If I go this way, I can do it in n-1 steps. And so basically, because we have limited our search directions to the left and down, we can reach every single position in a linear amount of time. So the execution time, or the time complexity, would be linear, and our space complexity, or auxiliary space, would just be constant, because we're not actually using the grid. We are just taking values and we're not storing them. So this is a implementation how you could solve this problem. If you enjoyed the video, leave a like, subscribe, and of course, thanks for watching.